All right, here's our part 2 video for graphing polar functions. We are still following these steps right here. So step 1, I'm going to label my theta values over here onto my polar grid. Now I'm going to identify my A over B ratio. So this 3 is my A value. This 2 is my B. So A over B is 3 over 2. And we want to figure out which scenario, I didn't know which way I wanted to say that we have from this condition row right here. Is that ratio less than 1? If A were equal to B, then that ratio would be equal to 1. Is that ratio greater than 1 but less than 2, or is it greater than or equal to 2? And this is the situation that we have right here. So we know we're going to have a limicon with a dimple. Our previous problem had the inner loop. This one's just going to come to a point and then pop back out. So because this was greater than 1 but less than 2, we have a limicon with a dimple. All right, so let's get started. We are going to be plugging our thetas in here and finding the value just like we did in the previous problem. This time we're doing cosines of thetas. So when we go to our unit circle, so for example, this first one is cosine of negative pi over 2. So here's negative pi over 2. Cosine is the x coordinate there. So the cosine of negative pi over 2 is 0. So we can plug 0 in for the cosine theta. Remember to do multiplication first before addition. 2 times 0 is 0, plus 3 is 3. All right, so we're going to go through this one a little bit faster than we did the previous problem. Cosine of negative, yes, ma'am. Yes. All right, 3 plus 2 times the cosine of negative pi over 3 is a half. So then half of 2 is 1 plus 3 is 4. Then 3 plus 2 times the cosine of negative pi over 6 is rad 3 over 2. That is approximately 4.7. Three plus 2 times the cosine of 0, which is 0. Sorry, 1. Sorry, my mint gum about killed me in my throat and I couldn't breathe or think for a second. So 2 times 1 is 2, plus 3 is 5. Now, the good news is for this next section of points, because these are all x values and x's in the first and fourth quadrant are the same sign, we can just repeat these values as we move through the remainder of the thetas. So pi over 6 is the same as at negative pi over 6, approximately 4.7. Pi over 3 is 4. And then pi over 2 is 3. Okay, so there's something happening here that didn't happen in the previous problem. In the previous problem, we had all the points we needed, these black ones, to fill out just using symmetry only. We knew this was vertical symmetry, and we've got the points all the way back around to that vertical axis, and so we just reflected everything to get the other side. The problem here is we don't have enough points to start our symmetry process, our reflection process right now. We know that this is going to be a limicon with a dimple, so it's going to come in and then back out, and we can tell that it's going to be symmetrical over this horizontal axis, so it has horizontal symmetry. So horizontal symmetry will happen when you have addition, and vertical symmetry when you have the minus. So to get enough points that I could just reflect the rest, I need to get points between here and the horizontal axis. Once I get points here, here, and here, I have enough to just finish with symmetry. So I'm going to create new values at these areas. So this pole right here is at 2 pi over 3. This one is 5 pi over 6, and this one is pi. So I'm just going to add these to my table. To get those new R values. So I'm just going to do the same thing I have been doing. The cosine of 2 pi over 3 is -1/2. So this is -1 plus 3 is 2. The cosine at 5 pi over 6 is -rad3 over 2, which is approximately 1.3. And then at pi, the cosine is -1, so that gives me -2 plus 3, which is 1. And so now I'm just going to reflect these. Oh, whoops. I knew I had done something wrong. I'm just going to reflect these over that vertical axis. And so here, this black section is what I got from the original table, and this red section is what I had to generate myself as I thought through the rest of the problem. Now again, you don't have to do 2 different colors, but you can see how this is a limicon with a dimple.